In this demo, I'll show you how to use SaskGlue to automate a simple data pipeline. Since data pipelines generally handle variable workloads, we want to utilize serverless and ephemeral compute as much as possible to minimize costs while scaling horizontally. We will employ these principles in our data pipeline demo. The basic functionality of our data pipeline is to perform some analysis on files loaded to an S3 bucket. The analysis we're going to perform is to simply count the number of instances of each word in the file. We will automate this process with 3 SaskGlue jobs: a file watcher job, a file analyzer job, and a job which will terminate an idle EC2 instance. Let's look at these jobs in a little more detail. The file watcher job consists of 3 tasks. Each task runs in AWS Lambda, so we're only paying for compute we're using. The first task checks for new files. If there are no new files, the job will terminate. Otherwise, the next task will run, which will start an EC2 instance where we will run the analysis process for each new file. This EC2 instance will be bootstrapped to run the SaskGlue agent and to configure it to run the file analysis job. The final task will kick off the SaskGlue job to perform the analysis for each file. These jobs will be kicked off via the SaskGlue API. We've configured the file analysis job to only run one instance of the job at a time, although we could configure it to run multiple instances of the job in parallel. The jobs will be executed serially until all are complete. After a configurable period of inactivity, the agent will kick off a SaskGlue job to terminate the EC2 host via the API. Let's take a look at the file watcher job in the SaskGlue job designer. This job consists of 3 tasks: check for new files, launch analyzer host, and run analyze jobs. The launch analyzer host task has an inbound route from check for new files with route code OK. This means that the check for new files task must complete with the route code of OK for the launch analyzer host task to start. As we'll see, the check for new files task script will only return a route code of OK if there are new files to process. Otherwise, the job will complete without the remaining tasks running. Similarly, we have a blank route code from launch analyzer host to run analyze jobs. This means that the launch analyzer host task must complete successfully for run analyze jobs to be started, since a blank route code indicates that no error occurred. All 3 tasks run in AWS Lambda, as we can see in the designer sidebar. Any SaskGlue task can be configured to run in AWS Lambda as long as the code being executed is supported by the AWS Lambda runtime environment. The way this works is very simple. SaskGlue creates a new Lambda zip file containing the script to be executed at runtime, registers it with AWS Lambda in a SaskGlue AWS account dedicated for this purpose, runs the Lambda function, and monitors the CloudWatch logs for related log messages, reporting those back to the API and from there to the browser in real time. For more complex Lambda scenarios, including running compiled code, you can create your own Lambda zip file and upload it as a SaskGlue artifact. You can set the script or zip file and other Lambda task parameters in the job designer, including the Lambda runtime, the max memory to use, a timeout value, and a semicolon delimited list of script dependencies. The check for new files task runs a Node.js script that checks for new files in a specific S3 location. Let's take a look at that script. We're using the AWS Node.js SDK to list the files in a given bucket with a given prefix with this list files function. If the function returns at least one file, we set the route code to OK, and create a SASCLU runtime variable named files with a comma delimited list of the new files. If there are no files, it sets the route code to nothing to do, which will cause the remaining tasks in the job to be skipped, as we noted previously. The Launch Analyzer host task runs a Python script that first queries the SASCLU API to see if we already have a running EC2 instance that can perform the file analysis. If not, it starts a new EC2 instance with a Bootstrap script that downloads the SASCLU agent, configures it with tags that designate it as an agent that can run our file analysis, and starts it. The third step, Run Analyze Jobs, runs a Node.js script that launches the SASCLU job that performs the file analysis for each file found by the Check for New Files task. The list of files is communicated from the Check for New Files task to the Run Analyze Jobs task via a runtime variable named files. We set the value in the file watcher script here, as we saw previously. And we consume the value in the script that starts the analysis jobs here. As each analysis job is launched, the name and location of the file to analyze is passed to the new job as a runtime variable called FilePath. We'll see in a minute how the analysis job utilizes the FilePath runtime variable. Let's take a look at our file analysis job. We've named the job File Analyzer. It consists of one task with two steps. In SASCLU, tasks in a job can run on one or many machines, but all steps in a task run on the same machine in the same runtime environment. The first step downloads the file to the runtime environment, and the second performs the analysis. We can see in the job designer that this task targets an agent with the tag task equals file analyzer. As I mentioned, the Launch Analyzer host task in the file watcher job configures the agent on the new host with that tag in the Bootstrap process. Let's take a look at the download file step. This step runs a simple shell script that downloads the file from the S3 file path to the task runtime environment. Notice the @sgg syntax here. The SASCLU agent will replace this string with the contents of the runtime variable with the quoted name enclosed in parentheses after @sgg, in this case, FilePath. This is the variable we passed into the job when it was created, as we saw earlier. The second step runs a Java program that performs the analysis. This Java program is in a jar file that was created from a Clojure script that performs a simple word count analysis of a file. To utilize this Java jar file in this task, we first uploaded it to SASCLU as an artifact using the Artifacts tab in the web console. Then we attach the artifact to the task, as we can see here. The final job used in this demo is called Stop Agent and Terminate EC2. This job will be started by the agent that performs the file analysis after it has been inactive for 60 seconds. We configured the agent to run this job and the inactive time threshold in the Bootstrap process. This job will do just what it says. It will stop and terminate the EC2 instance that calls it. Okay, let's see all this in action. I've uploaded two files to our S3 bucket location. I'm going to start the file watcher job manually from the web console. but you could easily run it on a schedule or kick it off via the API. To run it on a schedule, you'd click the Schedules tab in the Job Designer and click Create Schedule. You enter a name, choose a schedule type, either date, cron, or interval, create the schedule, and then it will run according to that schedule. In this case, I'm simply going to run it from the console by clicking the Run tab and clicking Run Job. I'm now going to click the Running Job link, which will take us into the job monitor for this job. We can see the job name, the status is running. We could cancel or interrupt the job. We can see the time that it started, and when it's completed, the time that it completed, and who it was created by. We can see each of the tasks in the job and their current status. The Check for New Files task is currently running, and it has completed already. We can see from the standard out that an AWS Lambda function was created, it was executed, and we can see the standard out, including our files runtime variable that was created with the 2 files that were found in our S3 location. The Launch Analyzer host step is currently running, and this is the step that will see if we currently have an EC2 instance that can perform the analysis of these 2 files that we just picked up, or if a new one needs to be created. And it's actually in the process of creating a new instance at this time. And when it completes, we'll be able to see the result in our standard out. We can also see that the tail updates in real time as the job or the task is progressing. So clicking on the standard out, I can see that a new instance was created in our Lambda function here. And the Run Analyze Job step also completed, which created our 2 SASCLU jobs, which will analyze these files. We can see the 2 jobs here. We can see that one of them is running and the second one is kicking off. Let's look at the results of the first task. We can see that the file was downloaded and that the Analyze File task was completed. Looking at the standard out, we can see all of the words in this file and the number of times each of those words appeared in the file. Very simple word count application. And similarly for the second file. Okay, at this point we're waiting for the job to kick off that will terminate this agent after a period of inactivity. Here we can see the agent, we can see the tags, task equal file analyzer, that were assigned to this agent in the Bootstrap process. We can see the inactive agent timeout and the inactive agent job, which is the job that will get kicked off after this timeout period is exceeded. We can also see runtime variables that will be passed into this job when it executes. And the timeout period expired and the inactive agent job did kick off and completed. If we go back to the agent screen, we can see that our agent that processed the files is now terminated. Okay, that's it for the demo. Hope you enjoyed it. Please check out sasglue.com for more information about how you can use SASGlue in your automation toolbox, or send questions to help@sasglue.com.